Okay, what a lineup. My word, there's more Zoes around there as well. And look at that, Citroen C0. Cool, retro. So I've wanted to do a video about Zoe Heating for a while, but I've not had cars in the right states. And also it's something I've been thinking on how to improve. Like, can we change the heating system to basically make it better? And I've managed to do that. And it's something I'm kind of testing at the moment, but basically what we're going to show is this car, which I've just finished for a customer, which has been picked up shortly by a truck actually. The heating works really well, absolutely fantastic. It's just been regassed and everything is working. So this is our example of a Zoe where the heating is working really well. Okay, the next car we've got has got no gas in it, so this is an example of a car that the heat pump does not work. And it's about 10 degrees ambient temperature out here, and that's important, and it will become obvious why in a minute. But yeah, so that one has no functioning heat pump. So it could be the compressors failed, whatever, or your heating is poor. So that one does not have heating, that car. This red car is one I own, and I've made a modification to the heating system. So this does not have a functioning heat pump because it's got no gas in it, and I've left it in that state, but I've modified it so it has heating. And we're going to talk about that next, but we kind of need to talk about how the heating system works and then what is possible and what is safe as well, and what we can potentially do to improve the heating on these Zoes. So first thing, if you're not subscribed, please do so. And also, if you're interested in sort of different kind of home maintenance for your Zoe, there's some member videos as well. So you can join the membership. The video access is $1.99 a month. And yeah, there's just lots of videos. You can request new videos and stuff like that. So yeah, link in the description. So here is a diagram which doesn't include everything, but it's kind of got most of it. This is from the Renault marketing material. So with a Zoe, you've got a slightly bigger system, but let's think about a standard air conditioning system first. So if we look at this top diagram, if we kind of like forget about this top bit for a minute, this is the compressor. So you've got a compressor and it pumps and it creates high pressure. If you've got your standard petrol or diesel car, that pipe will just go straight into the radiator basically. So the compressor pumps, the radiator gets hot and it gets cooled by ambient air. So this is kind of like lukewarm effectively. Then that lukewarm air goes through number 6, and number 6 is an orifice. Okay, what it is a fixed restriction in the pipe. Okay, so just imagine there's like a jet in there. So you've got high pressure because the compressor's pumped. Sorry, I'll try and keep still. The compressor's pumped, it's created high pressure. Let's just say that that has gone straight back into the radiator. Then this is still high pressure, but it's a bit cooler because it's been cooled down by the radiator. Over goes an aeroplane, and then it goes through this jet, so it expands. It's yeah, so literally just like a pinhole restriction in the pipe, and it expands, and then you get low pressure, and that cools down when it expands. Okay, because of science. So yeah, then that goes into the internal radiator inside the car. Then the blower motor, which is what that is, blows through, and you get cooling inside the car. Okay, fantastic. Now we've got all this extra stuff at the top, and all Zoes have a heat pump. Some EVs it's optional, like Nissan Leafs and stuff, but all Zoes have a heat pump. Okay, so with the Zoe, instead of the hot side from the compressor, the high pressure side, going straight to the front radiator, what it does is it actually goes to a second radiator inside the dash, which at the moment, you see that flap is against it, so the air's not going through it. It's actually just going into the dash and back out again. So even on a hot summer's day, when you've got your aircon in your Zoe, there's actually a second radiator behind the dash, which is hot. Interesting. And then that just goes back to the radiator. Now we've also got additional bits of pipes and valves and stuff. And what that means on a Zoe is that what it can actually do is turn the front radiator cold. So you see it was hot before, but now it's cold. Okay, so what it's now doing is the compressor is still doing what it's always doing every day of the year. It's pumping, it's got a low pressure side and a high pressure side, and it's pumping, okay? That hot goes to the cab like it always does, even in cold mode, but the difference here is that flap is open, so the air is going actually through the cold rad, which actually now has got nothing in it. Well, it's probably still got some gas in it, but it's got no particular temperature change. Then it's going through the hot radiator and into the cab, so we're blowing the air through both rads instead of up here we're only blowing it through one. Okay, so we're using that hot rad, and you'll notice that there's a valve here which is closed. sorry, a valve there that's opened. That the valve is the top one, and the bottom one is the fixed restriction. See number 6, like at the top, your orifice, as it's wonderfully named. So before, whereas there's a valve at the top and it was just going straight through, that valve was closed, so the restriction is now here. So whereas number 6 here was the, sorry if I put my finger in there, it focuses on that. So you can find this diagram online, by the way, if you just search for Renault Zoe Heating System, if you want to look at it more in detail yourself. So whereas the restriction was here in the system, the restriction is now here because this valve has closed. So that makes the front rad cold. And then what happens here is, obviously we don't want to go through this restriction because we've already been through a restriction, we don't want to go through another one. So basically it just bypasses the internal cooling radiator. This little 3-way valve moves and it goes back round to the compressor. So that's how the heat pump fundamentally works. So that's cool, we can understand that, makes sense. There are a few more things missing off this diagram. In addition, there is a battery cooler unit. So these cold pipes in cooling mode, there is actually some pipes that run straight underneath the car to another cooler unit, like this internal cooling radiator. There's another one for the battery, and that can be turned on and turned off as well as required. So sometimes when you charge, if it makes noise under the bonnet, it's cooling the battery. The other thing that's completely missing off this diagram and is not very well known is the Zoe actually also has an internal electric heater. Okay, and I've pulled off a cover panel because I own this car as well. These two are mine, the front one's a customer one. Got all the keys in my pocket. So underneath the dash, if you take off these cover panels, there's a lot of wires here and there's connectors in here which is slightly difficult to see. Just see there. So these are connected to a something. And what that is a 12 volt PTC heater, so a 12 volt electric heater. Okay, and what is that there for? So basically, when it's really cold and the car is trying to heat, so if you imagine this heating mode, imagine it's like -2 degrees outside, the car is trying to make this front radiator colder than ambient so that the ambient air can warm it up, okay, so that then when it goes through the background and through here, that you then get enough heating out of it. So it's trying to extract heat from the air, but if it's like -2 outside, that's extremely difficult to do. So that those connectors and those wires, where they're going at the bottom of the dash, is an electric PTC heater. It's actually something like 3 elements, I think. And basically under 5 degrees, which is why it's important that the ambient air temperature when we do this testing, under 5 degrees, those electric heaters turn on and provide you with a boost of heating. So you might find, so it's about 10 degrees now, you may have found with your heating, if it's poor, when it gets to 5 degrees and below, suddenly you've got heat, even though your compressor doesn't work, which is a bit bizarre, but that's why, basically, because there is, excuse me, a 12 volt PTC heater, which is giving you a boost, basically to help the heat pump. So let's just have a look at the operation of this car, because this one works. And apologies, this is going to get a little bit noisy, but I'm just going to demonstrate basically. So people say, my car is making a jet noise, it's really noisy, there's something wrong with it. I'm going to step back a bit more so you can definitely hear me. The heating system on the Zoe is noisy because it's got to run the pump and it's got to run the fans to cool the air, okay? So it makes noise, but it shouldn't rattle and it shouldn't grind. Okay, and this one works absolutely perfectly, so this is why it's a good example. Many thanks to the customer for just letting us use this before it gets picked up. So the compressor is here. I'm hoping you can still hear me. And basically the compressor makes that temperature difference. It kind of increases the pressure, but there's a little bit of a temperature difference between the two sides of the system. This is only just turned on, but if we get, let's say, that pipe, so we can see this is warming up, okay? This is what should normally happen. I wouldn't recommend touching these with your hands because they can get extremely hot and extremely cold because it works really hard. So we can see that's warming up, oh sorry, I moved the thing a little bit, but 21, 22 degrees, that is warming up that pipe, okay, on one side of the compressor. And then we can just use actually this one And if I keep still, so 9, 8, so that one's cooling down. I'm bearing in mind that there's a big rubber pipe and I've only just turned it on. That one is cooling down basically, and the longer that runs, it will create that temperature difference. And we've got it in heat mode, and that is just either side of here, basically the pressure. So we haven't actually gone through we're not going through the restriction. We're just doing either side of the pump. Okay, so let's have a look inside the car. I've got the diagnostic machine. It can show us some data and show us what's going on. And just to kind of prove that this does work, this is my meat thermometer, and we've got 46 degrees. Oh, it's lovely, nice and warm. 47, it is warming up. So this one is working really well. That's what should happen. But just to show what the car is exactly doing. So my pressure has gone up 16, that's not too bad. I have seen it higher than that. That's pretty good. So we've got inlet and outlet temperature. So this is quite useful because it's basically just the car's temperature sensors in the AC system, and it's generating a nice big temperature difference. So that's really good. Don't worry too much about those if you don't understand them. The important thing here is we've got the compressor spinning, but heating resistor power requested 0. Okay, interesting. So that's 10 degrees, and the car has not turned on those 12-volt PTC heaters. But I've got heating because my heat pump's working. We're all good. It's speeding it up and slowing it down. If I turn up the fan speed, then that compressor will probably spin faster. Yeah, so it's kind of responding to demand because I just turned up the fan. I think it tops out about 1800, but it's working pretty hard. And if I turn that, I just turned it off briefly there for a second, hence it went off. If I turn it down, I know it's kind of spinning back up again to meet my demand, but yeah, that will speed up and down, and that's how it's meant to work. Right, now let's move this diagnostic machine to the car that does not have the functioning heat pump and see what that's doing. One moment, please. Okay, so I have turned the heater on just like in the other one. You will notice this one is dead quiet. Okay, don't worry about the fact that the motor cooling fan is not there. That's just for some testing. But you can kind of see the compressor a little bit better with that out of the way. But this compressor is not switching on. In this case, it's because it's got no gas in the car. But it could be that your compressor is broken, or there's some other fault with the AC system, sensor fault. But if you don't have that compressor working, you don't have heating unless it's below 5 degrees. Star. Wait a minute and we'll see what's happening with the red car. So yeah, just to show that the other one made loads of noise when you turn the heater on, this one doesn't make any noise under the bonnet. What's actually going on? Well, the answer is not a lot. I'm not getting any heat, so I'll have to shut that door, it will keep binging. And the ambient, we've just got basically ambient temperature 11.1 coming out of the vents. See, we're in hot mode. We have actually got it set to top vent, so just for the sake of argument, I'm going to switch that to front vent. I'll turn that up a little bit, but yeah, we know the compressor's not working because nothing's happening under the bonnet. Just give that a second to let the air come out. Yeah, if anything, that's probably going to cool down, but yeah, 10.9, nothing, sorry about the reflection there, but we're not getting any heat. Okay, I'll put that on there in case it's in case you can hear it on the camera. So what's going on? So we've got basically no refrigerant pressure. The air conditioning system is not able to create a temperature difference because there's no pump and it's not pumping. The compressor is not spinning, and the heating resistor power is 0. So this is a classic example of a car where the heating just does not work. In some cars it can be weak, which is really annoying because it kind of works but it's mediocre. There are a few tricks online and things, you know, sort of different things. Some of them can work. There is something to be said for the hairdryer trick. There is actually a technical reason that in some situations that might actually work. But yeah, generally, if your heating's a bit naff and it's been naff for a while, it's probably still not really going to be very good. And there's not a lot you can do about it other than to get it properly fixed, apart from this sort of modification I've developed. So a customer recently asked me to get a new price for a compressor. The brand new price that I got from Renault Parts Desk was 1,089 plus VAT, which is 1,306 I think it was. But yeah, mad. That's for a brand new compressor. I generally manage to get decent stocks of second-hand compressors, or low mile compressors, and that's what I tend to fit basically, because you can do that for a reasonable price for the customer basically. But yeah, so this one doesn't work at all. I'm going to take this diagnostic machine, plug it into the other car which I've modified, and then we'll see what that one is doing and talk about how viable that is. All right, back in a moment. Okay, so this is my red car. Oh, there's a bit of wind, hopefully you can still hear me. Just to show that, so the heating system is on, just like it's been in the other two cars. First one obviously was making loads of noise because the heat pump was running. Second one, heat pump wasn't working, we had no heat. Third one, it's not doing a lot. The blower motor is on, but that's inside the car. The heat pump is not working. Okay, so let's have a look firstly here. So the heat pump is not on, but I've got 36 degrees coming out of here. Probably if I turn some of these off and just put that down and do this, we'll see how warm we can get it. 38, 39. Okay, the other one was giving us 47, but still we're getting a reasonable amount of heat out of this car, but the heat pump is not running. Okay, so what's going on? So yeah, we'll just let that run. Oh, it's nice and warm, but I will put it up there just in case it's giving us noise on the microphone. So refrigerant pressure 0 or 0.1 bar when it makes up its mind. So we've got no refrigerant pressure, refrigerant inlet and outlet. That's kind of just a, you know, like shows what the heat pump is doing, whether it's able to build a temperature difference, create a temperature difference by building pressure in the AC system. It's not doing anything, and just to prove it, compressor speed is 0, so the heat pump is not working. Heating resistor power requested 1800 watts. Now we're getting somewhere. So what I've done to this car, basically where I mentioned the 5 degrees, so under 5 degrees, the electric heater, which is down there, 12 volt electric PTC heater, will start turning on, and it turns on in about 3 steps, I think, which we'll probably try and demonstrate. Let's turn it down and see if we can get it to do different things while we're chatting. Go down a few degrees. It's about 10 degrees out here, isn't it? So even there we should, oh, it's gone to 14. Oh, and 11, 7. Oh, there were some clicks as well, and 4. There we go. Oh, and 0. Let's crank this up. That was cool. So I'm just moving the temperature on here, and that's what's happening here. So so this car now turns that electric heater on below about 17 degrees, not 5 degrees, because I kind of, just through calculation and just kind of, not really calculation, but yeah, just through thinking about when you want the heater on, you know, you set your house to 18 to 20 degrees. When it gets to 16, 17 degrees, you're wanting heat. And below 10, you really want heat because that feels cold. And if you're waiting for 5, you know, that's sort of like 14 degrees below. I mean, it can be 6 degrees outside and you've got no heating if your compressor doesn't work and you don't want to spend a lot of money on a new one. Maybe it's just an old car. I've done repairs for some people who are not really planning on keeping the car for a while. That was quite cool when it stepped down. So yeah, this car will turn on those 12 volt heating elements and give us heat. It's a bit lower just because I've been turning it up and down and we've got a massive reflection. But we have significant heat, bearing in mind it's obviously 10, 11 degrees outside. It's turned it off. Let's just whack it up just for the sake of argument. Yeah, so this car will turn on that electric heater below about 17 degrees instead of the 5 degrees. Now, up until this point, I've really shied away from doing any modifications just because you're always concerned if something goes wrong. Now, one of the other vehicles I own is a Vauxhall Zafira. And if you know about those vehicles, they had a bit of a habit of setting on fire. And it's very difficult to work out exactly what happened with these vehicles. But what we do know, what can be pieced together, is that those vehicles had a cutout on the resistor pack. So where it had the fan speed, there was just like 1, 2, 3, 4. So 1, 2 and 3, to achieve that, there was a resistor put in line with the blower motor, basically. And that was cooled by the air, that resistor pack that got warm because there was power being consumed by it to slow the fan down. It was a bit of a fairly simple basic system. Yes, so the air going through the blower motor cooled that resistor pack down, but it also had a thermal cutout fuse. So if it overheated, because obviously it was getting warm, it would cut out. And basically what it seems like is that this was happening. If you know more about this, please comment in the comments. What certain people were doing is getting a higher rated thermal cutout fuse and fitting that. So this is sort of back in the day. This started, so people were getting it from like Maplins and stuff, good old Maplins, and fitting that. And then some of these cars were catching fire. Now, it's really hard to tell whether they've, you know, it's the ones that were modified that were catching fire or not, whether they just had a flaw in the system. But yeah, my Zafira's had a couple of recalls, and one of the recalls was to put a massive sticker behind the glove box, like on the blower motor, that said, "Do not modify this system," sort of thing. So obviously, Vauxhall were quite concerned about that. But one of the other interesting things about the Zafira is, in right-hand drive configuration, the pollen filter is really hard to access. So what seems likely, but yeah, if you know more, please let me know, is that the pollen filters weren't being changed. It's actually getting really warm in it, sitting with this 37 degrees blowing at me. Yeah, the pollen filter wasn't being changed. The airflow through the dink dink, hope you can hear those dinks, it's quite satisfying. The airflow through the blower motor and through the pollen filter was poor. Then the resistor pack was overheating. And it wasn't a fault in the component, it was overheating because it was getting hot. But people, I think, potentially didn't change the pollen filter because it's buried. It's in a bit of a silly place, but it's made for left-hand drive, I think. And so they were putting a higher rated thermal fuse in. The system was running outside of its design constraints, and it was then potentially causing an issue. And this is why I've always really shied away from modification. So although this works, and I've done basically the most stupid things I can think of to try and cause a problem with this. So for example, setting it to max, closing all the fans, all the vents, sorry. So the fan is blowing, but it's hardly going out anywhere. So yeah, literally put it on max temp, shut all of these so that we know that those heaters down there are consuming best part of 2 kilowatts, but it's got nowhere to go. And, you know, trying to make it overheat, basically, because I own this car and I want to see what happens, basically. Obviously, I'm keeping an eye out and a nose out and see if anything interesting happens. But yeah, you know, leave it parked in the corner somewhere like this and just see what happens, just to make sure this is safe. So far, absolutely no issue. Haven't managed to cause any problems at all. I haven't looked at the pollen filter on this one. They're not usually particularly blocked, but it would be a good thing to check. But I kind of wanted this to be the worst. You know, what's the worst thing I could do? Well, ignore the pollen filter, it might be completely blocked. Well, it's not completely blocked because I'm getting airflow through, but you know what I mean. If it's got a few leaves in it, then that's brilliant because this is a test. Shut all the vents, whack the heater on. You know, if I put the fan, yeah, the fan speed is on 1, but I can still get max heating and it's kind of got nowhere to go. You know, just to make sure this is safe. But I've always really shied away from modifications. But yeah, I've thought this one through, and because I've changed the temperature at which it chooses to turn on, so I've modified its kind of like decision, or I've modified its inputs. That seems a lot safer than, I know there's some one modification that someone sort of documented where they basically just put in a switch and you could turn that heater on. And I sort of thought about that, and I thought that seems really dubious because you could leave that switch on. I don't know whether we're getting that switch power supply from, but if someone gets a permanent live to that switch and then the heater on, that heater could be running literally when the car's parked up, the fan is off, permanently running, and that's not going to go well. So although I don't like doing modifications, this, it seems like something potentially people might be interested in. Kind of let me know your thoughts. I really want this to go through some more testing. It doesn't take too long to do the modification. Yeah, it's not mega involved, but and it's also reversible as well. So yeah, probably takes about an hour to fit and then give it a quick test. Occasionally you have to disable the air conditioning compressor. I can't remember if it was this car. I think it was this car actually, yeah. That under preheat, the car would actually still spin the compressor, even though it's got no gas in it. And when you turn the heater on like this, it wouldn't spin the compressor. When you do a remote preheat with the key, because it's got that wonderful button on the key that makes the car warm, yeah, it would start spinning the compressor. So obviously we don't want that to happen, so the compressor control connector has been removed, so it cannot physically instruct the compressor. So there's a few things like that. You know, in a sort of finished version I would probably want to cap those connectors to prevent moisture, so we need some sort of caps and stuff like that. So it needs a little bit of finessing, this solution, but I am confident this is safe. but I want to give it some more testing. But that's potentially something I guess I could offer as a, you know, as a solution really, to put that modification in. It's always really makes me really nervous, and this is why I in the past haven't done modifications, because, you know, at the end of the day, if the car sets on fire, you've modified it, you're sort of playing with, you know, people's lives potentially. But then you trust your testing. Obviously I've done quite a bit of car repair, but I've always put it back to standard. And people say, oh, can you do this? Can you modify this? And I'm sort of like, well, you know, I've got insurance to repair cars, but I haven't got insurance to modify cars. You know, that's something I need to look at. But, you know, yeah, trust your testing. Maybe there's people out there who are interested in testing this as well. Yeah, let me know your thoughts. But this one I thought it was a good day actually, because I've got the cars in different states. I've got one that works really well, and we can talk about how it works and show how you check it works, all that kind of stuff. And then obviously we can compare to one that doesn't work at all, and then one that works but because of the modification. But also it's the right ambient temperature, because it's 10 degrees. That one's not going to heat at all. If it was like, yeah, 4 degrees, you'd get the same heating on that as in this. It'd be no different. But yeah, this is really made for these kind of days where it's cold. It's getting really warm in here. Sorry, I'm literally going to have to turn that off. Yeah, these days where it's a bit cold, and yeah, like I say, it could be 6 degrees, and you're getting no heating from your car, which is a bit naff. Some cars are quite old. Some, yeah, the really annoying ones, I have to say, is where the heat pump works, the compressor spins, but the sort of temperature gradient that the car can build in the heat pump is not very good. So like the compressor turns on, but it doesn't generate much of a temperature difference, and you're kind of like, well, why is it working but it's only working averagely? You know, customer says, what's it going to cost to make the heating better? You sort of think, well, that's really hard to say. You could swap the compressor, but maybe the compressor's not being told to spin at full speed. You know, maybe there's a blockage in one of the pipes, maybe one of the valves is stuck, because it's got to move those valves, as we showed on that diagram at the start, those, like the 3-way valve. If it doesn't fully close and a little bit of the pressure bleeds through, then you've not got as enough pressure, you're not building that temperature difference, you know. So, but you're kind of like, how do you test those things? They're the annoying ones, and they're probably the ones that could benefit from this modification most. Well, other than obviously the ones that yeah, the ones that have no heating at all. So yeah, let me know your thoughts. What I'll be really keen on is if other tests, you know, how can I double check that this is robust? You know, what do I need to do? Do I need to shove a bit of cardboard in where the pollen filter goes so that there is no airflow? So we're demonstrating maybe the situation where the pollen filter hasn't been changed for 10 years and is totally blocked. Albeit if I do this modification, I will be changing the pollen filter if it's not recently been changed. But yeah, just let's demonstrate, you know, because maybe I change it, but then they don't change it for another 10 years. They park it under a tree, gets loads of crud in the pollen filter. You still want to make sure that this is absolutely safe, you know. And we're not forcing the car to do something it wouldn't do. So we're not doing that. But what we are doing is making it do something under conditions it wouldn't normally do it. And I've thought about this because normally when this heater resistor turns on, it will be colder outside. So there's less chance of obviously a thermal event, as I like to call it, happening because of a colder ambient temperature. Albeit if you've got the heater on, the cabin is going to warm up. So you're going to have the same internal temperature potentially in the winter as you are in the summer. But then again, you could say if you haven't got it on recirculate, obviously the air temperature coming in is going to be cooler. So yeah, and that the heating radiator is up here and those elements are down there, so they're probably getting the raw air from outside. So, you know, in that situation the car will be getting cooler air than I'm giving it, albeit it obviously lets you, you know, if you've got a car that's not been modified, you know, so the car at the front, when it's 4 degrees, that one will turn on the heating resistor, and yeah, you could have it on recirculate then, so you could be feeding warm air into the heating resistor, so that doesn't seem totally different. But yeah, it seems a shame to keep this one under the can just because I'm a little bit nervous when it seems so robust. Yeah, there is always insurance to think about. I wouldn't want to do anything in any way would endanger anybody. That's obviously a complete no-no. So certainly any switches that just force those elements on, absolutely just forget it. Just do not do that. But yeah, what could we do? What can we do to make sure this system is safe? and how do we kind of get this to people's cars if they want it. Yeah, interesting thoughts. Yeah, cool. Do I need to get people to sign a disclaimer if I'm going to fit this? I don't know. Yeah, let me know your thoughts. If you, especially if you do modifications, maybe you do custom batteries, or you do something, any kind of car modifications. If you do, you know, JDM imports with, you know, wheels at wonky angles or whatever, what kind of insurance have you got that you're, you know, you're happy kind of thing? Does the customer sign a disclaimer? I don't know. I've never done modifications, so it's completely new to me. But please let me know your thoughts. Let me know what your heating is like. That'll be really interesting. Maybe we can gather some more data. And yeah, I need to turn this off again. It's too hot. I love the way that's. You can hear those clicks. Here you go. It's got so many gradients. I'm sure it's got 3 elements when I looked at the wiring diagram. But yeah, I'll have to have another look. Have a look on all data and see what's on there. Interesting. Yeah, quite like those clicks, but that's quite cool. But yeah, I've been driving this car around for about, I don't know, 3 weeks or something, with a heating like this, various temperatures, sometimes really cold. I have to say, when it's really, really cold, this system doesn't quite keep up, because it's only 1.8 kilowatts, and Nissan Leaf, the heater in those is 4 to 5 kilowatts, I think, depending on the configuration. A Kangoo, the electric heater, is 4 kilowatts. If I move my hand, focus, yeah. So it's not mega powerful, but it's a ton better than nothing. I can guarantee that. This car would have been really uncomfortable with nothing, but with that heater, yeah, you can do preheat on it, and does that okay, melts the ice off it. It's pretty good, yeah, once you disconnect the compressor, obviously. So yeah, let me know your thoughts. It works well, but I'm a little bit nervous about it. But, you know, how can we sort of get this out there? All right, cool. Well, thank you for watching. Please subscribe, and also consider the membership. And yeah, comments below, and I will catch you later. All right, cheers.